I'm Michael.
I'm Jose.
And I'm Ryan, and today we will be showing you about some of the properties of Reynolds number and what happens when it's big and small.
So here we have Reynolds number. Reynolds number equals the diameter times the density times the velocity, and that's all divided by the viscosity. So units are really important to know. So diameter is meters, density is kilograms per meter cubed, and velocity is meters per second. Viscosity is Newton seconds per meter squared. So at the end, you're gonna find out that Reynolds number is unitless. Like a really good example to explain Reynolds number is while you're driving your car like at around 100 miles per hour, and raining is falling on your windshield. So since water has a really low viscosity and your velocity is really high, you can technically neglect the viscosity because the water is just gonna slide off your car. So if the velocity is really high and the viscosity is really small, then the viscous forces can be neglected. But in our experiment today, we're gonna stir and unstir the corn syrup. So in our experiment, our viscosity is gonna be really high, while our diameter and density and velocity are going to be really low. And to go more into detail, I'm going to hand it to Ryan.
Good talk, I'd say.
So the diameter of the vessel that we're using is 2.5 inches, which is about 0.064 meters. From the internet, we can determine the density to be 1.4 grams per milliliter, which is 1,400 kilograms per meter cubed. The viscosity is 6.535 newton seconds per meter. So the velocity we can estimate because we know the diameter, so we can judge the circumference. And if we rotate it, if we stir at a rate of 1 rotation for every 5 seconds, then we will get a velocity of 0.04 meters per second. So Reynolds number is 0.064 meters, 1,400 kilograms per meter cubed, 0.04 meters per second, divided by 6.535 newton seconds per meter squared to give us a Reynolds number of 0.543. In terms of Reynolds number, that is very small. So why don't you tell us what happens when Reynolds number is just that small, Michael?
Thank you, Ryan. And so in my equation for the Reynolds number, that viscosity is very big. So whenever the viscosity is very big, you can neglect the diameter, density, and velocity. And so whenever you neglect those, then the Reynolds number would equate to 0. So in our Navier stokes equation that we've done some research over, you can neglect that Reynolds number be 0. And so whenever we neglect that Reynolds number, that means that you can also neglect that time. So you essentially neglect acceleration. And when you neglect acceleration, all you have is pressure and plus viscosity. So essentially, whenever you only have pressure and viscosity, that means whenever you go forwards in our experiment, clockwise, that the food coloring will essentially, whenever you stir it, you can go counterclockwise and it would remain at the same location.